You know that old Silicon Valley motto, right? The one that was basically painted on every office wall for the last 20 years. I mean, move fast and break things. Oh yeah, it's practically the battle cry of like 1,000 tech startups. Just write the code, push it live, and well, if something crashes, you just patch it tomorrow. Exactly. Pure, unadulterated speed over literally everything else. And it is this incredibly romantic image. You know, the lone developer in a hoodie fueled by caffeine, just typing furiously into the night. Launching features at 2 in the morning without asking for permission. Right, it was a badge of honor. But I want you to imagine waking up at 3 a.m. to a totally different scenario. Imagine a single automated script deployed into your company's network, and it runs flawlessly instantly and at a scale no human could ever match. But it contains this tiny logical error. Oh no. And within 5 seconds, it has permanently deleted the core user database of a major hospital network. Yikes. Yeah, no human pushed the button. No human reviewed the code. It just moved fast and broke absolutely everything. And that is the exact nightmare scenario, keeping Chief Information Security officers awake right now. Because, well, we've introduced a radically new element into that old startup environment that developer isn't just a human anymore. Right? It's an AI model capable of generating and executing thousands of lines of code a minute, which brings us to our mission for today's deep dive. We are looking at a massive structural shift happening right now in the tech world. We're going to explore exactly why large companies, the ones building the digital infrastructure you rely on every single day, are suddenly enforcing rigid structured controls when they use AI coding agents. Yeah, the era of pure hype is completely over. And this new era of serious, heavily regulated operations has officially begun. And we have some fantastic source material today to help us chart this transition. We're looking at a daily AI developer news roundup covering 4 seemingly separate stories. Yeah. At first glance, they might look like unrelated updates about, niche software tools, but as we dig into the mechanics of how these tools actually work, you'll see they all point to one undeniable trend. AI is basically forcing the entire software industry to grow up, and I want to say this right up front to you listening right now. Even if the phrase enterprise software supply chain makes your eyes totally glaze over, this matters to you. It really does, because every app on your phone, every banking portal you log into, every digital system you trust with your personal data, it is increasingly being built by AI. Today, we are looking at the exact mechanisms companies are putting in place to prevent those AIs from accidentally bringing the whole system crashing down. The tools themselves are changing, but what's really fascinating is how the human environment surrounding those tools is being forced to adapt. So let's start with the first piece of our source material, which really frames this whole shift. OpenAI has just been named a leader in Gartner's 2026 report on enterprise AI coding agents, and Gartner is the big leagues. When you land in a report like this, it means the massive corporations, the global banks, the healthcare systems, airlines, they are officially buying what you're selling. Right. And the source points out that OpenAI's codex now reaches over 4 million people every single week. But the real story isn't the volume of users. No, it's the fundamental shift in what the AI is actually permitted to do. The distinction the source makes here is between an assistant and an agent. Okay, let's unpack this, because I think that's a huge distinction for someone new to enterprise software security. Help us understand the mechanical difference. What does an agent do that an assistant doesn't? Well, think of it like a kitchen, right? The early AI, which was basically yesterday in tech time, was essentially a very fast sous chef who only knew how to chop vegetables, like just prepping ingredients and handing them over. Exactly. They stand at their station. They chop carrots at the speed of light and hand them to you. They make a mistake, you just get a weirdly shaped carrot. You throw it out. No big deal. Right. But an AI agent is entirely different. It's like hiring an autonomous head chef. This entity designs the menu, calls the suppliers, orders the ingredients, cooks the meals, and plates them up. Wow, so they aren't just suggesting code anymore. They're independently navigating the whole code base. Precisely. Codex can now understand massive, complex code bases spanning millions of lines. It can independently select which software tools to use to solve a problem and, run its own automated tests. It is moving out of the developer's isolated sandbox and stepping toward the live environment. And obviously, if you give an autonomous head chef the keys to your restaurant, you can't just leave them completely alone in the dark. No, you absolutely cannot. You need health inspections. Yeah, You need a locked door for the expensive pantry. You need a manager actually checking the receipts. In the software world, this translates to replacing pure speed with strict governance, which is exactly why the source highlights that OpenAI is aggressively building out enterprise controls. I mean, we are talking about approval gates, meaning the AI can draft the code, but a human must physically click an approval button before it merges into the main project. Oh, that makes a lot of sense. Yeah, and role-based access. So the AI inherits the exact same security permissions as the human using it. That way, an intern's AI can't accidentally pull up the CEO's database. So they are selling safety, auto workflows, and essentially the ability to hit the brakes. So the AI has basically graduated from a clever toy to serious heavy infrastructure. But I mean, if you're going to trust this AI head chef to run your incredibly expensive corporate kitchen, you need to know exactly how it operates. You can't govern a black box. And historically, that has been the central tension with AI. You take a prompt in to avoid billions of parameters, do some incomprehensible math in the dark, and an answer will just magically appears, right? But developers, especially those responsible for keeping banking systems online, inherently distrust magic. They demand to see the mechanics, which perfectly brings us to a really interesting piece of news in our source. GitHub just open-sourced their Copilot for Eclipse plugin. They released it to the public under the MIT license. Yeah, this is a big deal. And for the non-developers listening, Eclipse is an integrated development environment, or an IDE. It's basically the digital workbench where developers actually sit down and write code by open-sourcing this specific plugin. GitHub is letting developers look under the hood of the AI integration. They are publishing the blueprints of the wiring. Developers can now inspect the code that handles how the chat features work, how the code completions are generated, and how the agent mode operates within that workbench. But I want to play devil's advocate here and push back on this a little because the source explicitly notes a major caveat. This doesn't make the entire AI system open, does it? No, not at all. Right, because we aren't getting the neural network, the weights or the training data of the massive open AI model that actually powers Copilot. Exactly. The core brain remains completely proprietary. You aren't getting the secret recipe for the sauce. So if the core brain is still this giant black box, how does open sourcing just this one plugin actually help build any trust? Because while you don't get the brain, you get the entire nervous system like that. Yeah, you get to see exactly how the orders get from the waiter to the chef, how the chef accesses the pantry, and how the food gets routed back to the dining room. What's fascinating here is one specific detail the source mentions. This open source release includes the integration for MCP. Okay, let's stop right there. MCP. What is that, and why does a huge enterprise care if it's inspectable? So MCP stands for Model Context Protocol. You can think of it as a universal translator between the AI model and your local computer. Got it. If an AI agent wants to read a file on your hard drive or query a local database to understand your specific company's code, it uses MCP to do that securely by open sourcing the MCP integration. GitHub is basically letting security engineers verify exactly what data the AI is grabbing, how it's transmitting that data, and ensuring it's not, quietly leaking sensitive information. That makes total sense. As these assistants become more agentic, meaning they take independent action, the demand for visibility just skyrockets. You might tolerate a little mystery if the system is just suggesting a line of text for an email. Sure, but if the system is planning your software architecture and pulling files from your local machine, you demand absolute transparency into its supply lines. It reveals a major shift in developer psychology, really. They want an inspectable, modifiable system for AI to become serious enterprise infrastructure. It has to be auditable by the very engineers who rely on it. So we've opened the black box so the humans can understand the AI's wiring. But there's a flip side of that coin. If an AI is going to safely plan work and write code for us, it actually has to understand us. Oh, it has to read our project boards and comprehend our goals. And let's be honest, human workflows are incredibly, notoriously messy. Messy is an understatement. If you look at how human software teams actually communicate, it's utter chaos. We use shorthand, we invent inconsistent labels. We leave half-finished thoughts and project trackers. It is an absolute nightmare for a machine trying to parse intent, which perfectly transitions us into the third story in our roundup. GitHub is rolling out something called issue fields into public preview for GitHub organizations. Yeah, so let's look at the before picture previously. Developers would organize their tasks, which they call issues, using simple text labels. Someone might tag a critical bug as high priority. Another developer might tag an identical bug as urgent, right? Or someone else might just type fix ASAP in the description. Exactly. There was no standardized structure. The source actually calls this messy label sprawl. Here's where it gets really interesting to put that in plain English. Imagine trying to organize your family's entire life finances, schedules, chores, using a chaotic flurry of multicolored sticky notes slapped all over the refrigerator door. Oh, I know that fridge. Right. Some notes have dates, some just have names, some are literally falling off the fridge entirely. Now imagine asking an AI agent to look at that fridge and execute the most important task. It has no idea what to do. It can't confidently calculate priority because urgent and fix ASAP are just arbitrary text springs to a computer. It might prioritize the wrong task completely, or worse, delete something critical. So what's the fix? The source says GitHub is now allowing teams to define typed metadata at the organizational level. How does it translate from our sticky notes analogy? Well, it's the transition from a messy fridge of sticky notes into a clean, strictly enforced digital spreadsheet. With typed metadata, you aren't just typing free text. You are creating a specific rigid field for a number, a specific field for a date, and a drop-down menu with restricted options for priority. So you literally can't just type whatever you want. Exactly. And once the organization sets these rules, they apply universally across every single project repository the company owns. But the source points out this isn't just about making the project board look prettier for middle management. It says this structured data connects to REST, GraphQL, and webhook workflows. If I'm not a backend engineer, break those mechanisms down for me. Why does the AI care about a webhook? So let's break down the mechanics. If an AI agent wants to take action, it needs ways to ask for data and ways to trigger events. REST and GraphQL are essentially highly organized librarians. They allow an automated script to request very specific information. Like, give me every task where the effort field is a number greater than 5. Right? Exactly. And a webhook is like a digital tripwire or a doorbell. You can set it so that the moment a human changes a task's priority to critical, the webhook automatically rings the doorbell the AI agent, waking it up to go write a patch. But the AI can only interact with those librarians and tripwires if the data is clean in the first place. Exactly. Clean data is the absolute prerequisite for safe AI automation. If the data is unstructured text, the AI rings the wrong doorbell. By forcing human developers to use typed metadata, we are literally structuring our own human messiness into a machine-readable format. We are building a paved road so the AI doesn't trip over our chaotic communication. Okay, let's synthesize the journey we've been on so far. We are dealing with enterprise-grade AI agents acting like autonomous head chefs. To manage them, we implemented role-based access and strict governance. To trust them, we demanded visibility into their tools, open up the blueprints via the Eclipse plugin. And to help them understand our goals, we forced our humans to use structured metadata. So our internal house is completely in order. It is, but modern software isn't built in a vacuum. Your internal house might be perfectly secure, but your application still relies heavily on the outside world. And that is where the most terrifying vulnerabilities exist today. Right, we're talking about the software supply chain. Yeah, which brings us to the final piece of our source material. There's been a serious security update to NPM. Now, if you aren't familiar, think of modern app development like building a massive Lego castle. Almost nobody manufactures their own plastic Lego blocks from scratch anymore. Right, I would take forever. Exactly. You go to a massive global factory and you download millions of pre-built free blocks, things like calendar widgets, login screens, or data processors, and you just assemble them. NPM is that global factory. It's the largest software registry in the world. And if an AI agent is writing your code at lightning speed, it is also reaching out to NTM and pulling in those external Lego blocks at lightning speed. So what did GitHub do here? They just announced that staged publishing is generally available on NPM. To understand why this matters, you really have to understand how a supply chain attack actually happens. A bad actor doesn't usually try to brute force hack a bank's main server. That's way too hard. Yeah, they get caught instantly. Exactly. Instead, they find an obscure free Lego block like a tiny piece of code that formats text, for instance, that millions of developers already use. The bad actor compromises that tiny package, quietly slipping a few lines of malicious code inside it that steals passwords. And historically, the moment they hit publish on that poison package, it was instantly live. If your AI agent was building an app 5 seconds later, it would blindly download the poison block and deploy it directly into your company's infrastructure. That is the extreme vulnerability of instant publishing. Staged publishing fundamentally changes that mechanic. Now, when an update is pushed, it doesn't go live immediately. It goes into a quarantine area, a staging queue. Okay, so it just sits there. It just sits there, explicitly requiring a human to review it and pass a two-factor authentication or 2FA check before it ever sees the light of day. The source also mentions that the new version npm 11.15.0 adds granular install source controls. Things like allow file, allow mode, allow directory. What do those actually do in practice? They basically allow enterprise security teams to lock down the AI's passport. If an AI agent tries to install a package, these new rules can dictate. You are only allowed to pull files from this one specific pre-approved internal directory. You are explicitly denied from pulling any random files from a remote internet server, so it severely restricts the agent's freedom of movement. Precisely. But I have to push back here because looking at this from a high level, it feels somewhat contradictory. Isn't the entire value proposition of AI supposed to be eliminating bottlenecks? We literally just talked about how fast these agents are. Why are we intentionally adding friction, staging queues, and human 2FA checks that completely slow the whole automated process down? Well, this raises an important question, right? Consider the alternative. Without that friction, the damage scales infinitely faster than the solution. It's a lot like airport security. Oh, nobody likes taking off their shoes and emptying their water bottles. No, it's annoying. It's total friction and it absolutely slows your journey down. But we do it because the global aviation network is so massively interconnected. One bad actor slipping through the perimeter can bring down a whole fleet of airplanes. Right. In the software world, NPM is the airport, and they are intentionally installing metal detectors and passport checks in the exact spots where supply chain attacks like to hide. Because when an AI can pull dependencies and write integration code in milliseconds, a single malicious package could infect a bank's core system before a human even finishes their coffee. So the friction isn't a flaw. It's literally the defining feature of a mature system. Absolutely. So what does this all mean for you, the listener? When you step back and look at these 4 distinct stories side by side, the pattern is glaringly obvious. You've got GitHub forcing teams to structure their human issue data with rigid metadata. You've got Copilot tooling becoming open and inspectable, so engineers can scrutinize the AI's wiring. Yeah, you have OpenAI's codex being evaluated by Gartner as serious enterprise infrastructure, requiring strict approval gates. And you have NPM actively throwing friction into the global software supply chain with 2FA and quarantine queues. They're completely different stories, affecting completely different layers of the technology stack, but they are all marching toward the exact same conclusion. AI development is exiting the hype cycle and entering the operations phase. AI agents are forcing the entire environment around them to become highly structured, heavily governed, and completely transparent. You can't let a machine run 1,000,000 miles an hour on a dirt road. You have to pave the road, put up steel guardrails, and install traffic lights. Exactly. The next phase of the tech industry isn't going to be a competition about who has the smartest AI model or who can generate 1,000 lines of code the fastest. The winners will be the companies who can prove their environment is organized and secure enough to let that AI work without burning the building down. AI coding has grown up and well. Adulthood requires absolute control. It's a total paradigm shift. Move fast and break things has officially been replaced by structure your data and verify absolutely everything. For sure. But I want to leave you with a final lingering thought to ponder as we wrap up this deep dive. Throughout all of this, we've talked about how we are relying on human friction. We were relying on humans clicking a 2FA button, humans reviewing the quarantine queues, and humans setting up the strict governance to keep these incredibly fast AI coding agents in check. Right. But as these enterprise models scale to millions of users, and the sheer volume of code being written just rockets, how long will it be until companies realize that human beings are simply too slow to manually manage all those gates? Oh, wow. How long until they start deploying other AI agents just to enforce the enterprise controls on the coding agents? And when that happens, who watches the AI when the watchers are also AI? Now that is a truly fascinating and honestly slightly terrifying problem for the next era of security. So open to chew on while you wait and line at airport security. Thanks for joining us on this deep dive. We'll catch you next time.